So you see on either side we've got many dinosaurs, we've got skeletons, and this is really reconstructing what the Earth was like 65 million years ago. Now of course on this side we have Tyrannosaurus rex, very iconic dinosaur, and on this side we have Triceratops. And now I'm going to tell you a bit more about T-Rex when we get up to this head level, when we go up on the second floor. But what I can tell you is that these skeletons, this is a question on the last tour actually, these skeletons, do they have any real bones in them? And the answer is no. These skeletons and also recreations of the skeletons. Now because they're made of fiberglass, they are a bit fragile, but these are casts, they're models, and you'll see up above there's another skeleton, another cast. Now this one is very special because this skeleton is cast from a real fossil skeleton which was found a few years ago at Lake Diefenbaker. So they were doing some construction around that area, and they dug deep enough to uncover these 65 million year old rocks which contain the bones of this mosasaur. Now the mosasaur looks like a dinosaur. He's very fearsome. He's got sharp teeth, but the mosasaur actually wasn't a dinosaur, and neither were these flyers over here, these pterosaurs. Both of these belong to different groups of reptiles. The mosasaur was more like a Komodo dragon or a mongrel lizard. So there was a group of those types of lizards at the same time as dinosaurs that got close to the water. They became evolved for eating fish and living in the ocean. Whereas the pterosaurs were kind of like a sibling group of the dinosaurs. They both share a common ancestor at some point, some kind of reptile that lived, and its descendants grew into both the dinosaurs and the pterosaurs. You'll see at the feet of the T-Rex, there's a head of another dinosaur. That skull belongs to the Edmontosaurus. The Edmontosaurus, you may catch that it's named after Edmonton, which is where it was first found. And the Edmontosaurus was really a lot like the wildebeest of its time. It was a herbivorous dinosaur which would have been preyed upon by the likes of the T-Rex and other meat-eating dinosaurs. So now we're going to go into this sort of maze of examples. Stegosaurus showed up many, many millions of years later. And actually, a fun fact, this time, the period of time between the Stegosaurus and the T-Rex is longer than the period of time between the T-Rex and us humans. So that shows you just how long these big dinosaurs were roaming on the Earth. They were around for such a long period of time. But the Stegosaurus is a very iconic dinosaur, very famous for those spikes on the end of its tail. It would use those 4 big spikes to defend itself against predators. And actually, there are skeletons of meat-eating dinosaurs with puncture holes in their hip bones which perfectly match the tip of the Stegosaurus' tail spikes. So, definitely not a dinosaur you would want to cross. And then, we have the plates on its back. Now, it's a mystery what these were for. It's hard to say, really. Maybe they helped with warming up or cooling down if they were covered in blood vessels. Maybe they would have been useful for that. Or maybe, and this is maybe more likely, they could have been useful for impressing other Stegosauruses. So if there was a male Stegosaurus whose plates were bigger or more colorful or more impressive than the plates of another, he would be the one to be able to mate with the female. Whatever Stegosauruses were doing that. Yes?
Maybe he can use that to defend himself.
Maybe. It certainly makes them look bigger, doesn't it? It makes them look very scary. So it has 3 toes. If you look at the feet of this Mesohippus, you'll see it has 3 little toes on each of its feet. But that's going to change pretty quick as well. It's starting to develop hooves. So they still have 3 toes, but now 2 of them have become really reduced. They've shrunk it. And now they don't even touch the ground. Now only the one central toe touches the ground. You also see that the legs have gotten longer. That's because these horses were no longer living in a cramped rainforest. Now they were living in the open plains. They could run around. And when you're living on the open plain, it makes sense to have very long legs. No degradation or replacement by minerals in rocks. They haven't really been fossilized the way dinosaur bones have. This tree stump here is the exact same tree stump which once grew in that Arctic rainforest 50 million years ago. You could burn it just like regular wood, you could make carvings out of it. Anything you can do with wood nowadays, you could do with this. And so it's perfectly preserved, and there's also leaf litter, pine needles, all these different things, remains of plants frozen on this island. And actually, University of Saskatchewan was the one of the institutions which led the research on these ancient rainforests. And so this was discovered by them. They went up to the Arctic Circle, retrieved these samples, and you can actually find them pretty much everywhere today in the geology collections of the university. And just see how many different types there are, right? How diverse our rocks and minerals are. Many different colors, different shapes, and this is all to do with the chemical properties of the compounds and chemicals which give rise to these minerals, these big crystals. Yes? Used to grab and manipulate and crush open food like those trilobites on either side. Oh, and one more thing, sorry, I almost forgot. One more thing before we leave this cabinet. You'll see on the rock on the left, which is not much older, not much younger than those Burgess Shale rocks, is this big piece of limestone with many unusual shapes running across that look like train tracks almost. Those are the fossilized trackways of things that were probably like the trilobite, which were crawling around on the ocean floor. And those are called trace fossils. And here at the University of Saskatchewan, we are actually Canada's leading university for the study of trace fossils and other things that animals make when they move through their environment, whether it's footprints or trackways or just other ways that animals leave their footprint and make their mark on the world.